recording again. All right, so we should be good to go here. So don't forget you've got a quiz. Have it done by 3, please. We were talking here yesterday about the substituted hydrocarbons. Substituted hydrocarbons are easy-ish, not too bad once you get the hang of them. The problem is people have trouble getting the hang of them. So if at first they seem confusing, don't let yourself get too frustrated by it. You'll get it sooner or later if you keep trying. So we talked about halides. And if you remember, the halides contain at least one halogen, and the X here stands for halogen. It could be fluorine, chlorine, bromine, iodine, or astatine, any one of those 5. Usually not astatine, but I guess it's possible. Chlorinated hydrocarbons, in other words, halides that have chlorine, are what the big stink was in aerosol cans back when, that they took the fluorochlorocarbons, they had fluorine and chlorine in, that were supposed to be, maybe they were, I don't know, digesting the ozone layer. They haven't had fluorochlorocarbons in aerosol cans for, I don't know, I think 30 or 40 years. Occasionally you'll still see a can that says contains no fluorochlorocarbons, but none of them do. That's just advertising hype. Okay, you'll remember that alcohols had to have a hydroxyl group, which is the same as the hydroxide polyatomic ion, OH. The dash here means connected to something, like CHHH bonded to OH. This dash is, whoops, not that, sorry. This dash is this bond right there. Those 2 dashes are the same. That does not mean minus, it means a bond. Keep in mind also that they had the OH and they had no other oxygen on that carbon, not someplace, but on that carbon. All right, so third, and I don't know if the 3 is out of place on your notes or not, but 3 goes with ethers. So on an ether, you've got an O between 2 C's. Notice that there is a single bond on the right and a single bond on the left, and it is between the 2 C's, not like whoops, where'd it go? Not like aldehydes. My wife has the stylus for my tablet, so I'm using my finger, and it's not all working as handy as I'd like to on the tablet screen here. Not working handy at all. Switching back to laptop mode. I don't know how that'll work writing on the screen with my finger, but all right. So right here is where we were. You had the O between 2 C's, not an O on 1 C with a double bond in it, 2 lines. That was an ether. And remember, the R's are just regular C's and H's, any combination of C's and H's. And actually, this C right here could be counted as part of the R. You could write this R, O, R. So basically, you could have an O and a C and another C and H's coming off of those, and then a C and another C and H's coming off of those. And so this whole thing together would be an ether. And if you do like this, then it's the ether bunny. Ha 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 ha. So, come on, if I can hit that down arrow with my fat finger. You will remember that aldehydes and ketones are the same thing, except for where the C, the double bonded O is. So a simple one, if I had C, 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 if the double bonded O is on an end. By the way, the front is the front end or the back end. And these are basically the same because, hey, wait a minute, I'm at school, I can do my kits. These, the O here on the right would be the same as the O if the O was on the left, because maybe I can do my kits. There's still a little, there's still a few lifesavers left here. I could flick them at you, but I'd probably break my screen. Never mind, looks like my kit disappeared. Well, I'm sure it's here someplace, but I don't remember where. Ah, there it is. Just didn't look under one more sheet. All right, so watch this. I'll turn the camera back on here. And what do I want to do? How do I? Somehow, I don't do this enough to be real good at it yet. I think I have to stop the sharing. There. Now, for me, I'm a whole big screen. Sorry, you have to look at that. I hope I'm the whole big screen for you. So we had 3 C's. So we've got the black ball as a C. Now the black ball is bouncing around the floor. So the black ball is a C, and the little gray bar is a bond. And 2 C's with a single bond, 1 bar. A double bond would have 2 bars, a triple bond would have 3 bars. And by the way, so there's 3 C's, and you can see how they actually make a zigzag. I'm going to take it off, but I'll show you really quickly that if I put another C on here, that you can see that it is zigzagging. But the picture I had on the screen a minute ago was just 3 C's. So a C, and the white balls are H's. So I've got a C with 2 H's. And let's see, and then fill up the end, an H, and an H, and another H. So now I have to fill up this end, an H. I'm all out of ones that already have pins in, so I have to add the pins. So now I've got this nifty little 3-carbon hydrocarbon. Formula would be C3H8. This would be the formula for butane, the stuff in the cigarette lighters and so on, or campfire lighters if you don't smoke, or burn the building down lighters if you're an arsonist. Now, if we're going to substitute this, what was I doing? Double bonded O. So I think blue is oxygen. Nope, red is oxygen. I knew that. Blue is nitrogen. So this red ball is an oxygen. And I put 2 pins in it, like so. These ones, that's terrible English, are flexible, so that 2 of these hydrogens can come off. 1. Come on, I need the short pin to come out. 2. And I've only got 1 oxygen left on, 1 hydrogen left here. And okay, notice that's an aldehyde. That would be propylaldehyde because it's made from propane. It has a double bonded O on the end. 2 sticks, 2 bonds. It is zigzag because that's the way they really are, even though we write them as a straight line. And the double bonded O is on, as you look at it, the left. Now, would it be something else if the double bonded O was on the right? Okay, watch closely. This is really tricky. Same thing, just pointing in a different direction. Same thing, just in a different direction. Same thing, just in a different direction. So, doesn't matter if the the double bonded O is on the front end or on the back end, same thing. Now, look at this, aldehyde. Ketone is almost the same. It's made of the same things. But if I take these 2 hydrogens right here off, need the short pins, and they are hard to grab a hold of, and they're pretty tight. So I took those 2 middle hydrogens off. Right there they are. If I can figure out how to get my hand in front of right there they are. I take this off. See, just took it off and put it on the middle one. Take these 2 hydrogens and put them on the empty space on the end. Now, instead of being an aldehyde with the double bonded O on one end or the other, it is a ketone because it's on one of the in-between carbons. Now, people tend to think end versus middle, and especially this one where there's only 3 carbons. There's the end and the middle. But be careful with the end versus middle business, because why? Because it doesn't, a lot of people say middle and they think center, and it doesn't have to be on the center. It just has to be not on the end. And if I hold it like this, people say, well, this is an end because you have the, well, for me it's left, but I guess for you it'd be right end and the left end. No, it's not really an end. If we put that other one on, and had the zigzaggy, it really isn't an end, it's just part of the zigzagging. Now, by the way, the ether, as long as we got the kit out, let's show the difference between aldehyde, ketone, and ether. So we started with an aldehyde, it was on the end. Then we had a ketone, it's not on the end. An ether still has the red ball. Yep, can't point the camera down to show it rolling there. But instead of the red ball being double bonded on just one carbon, the red ball the red ball still has two bonds, but one bond goes to one carbon and the other bond goes to the other carbon. And then, of course, we would need hydrogens to go here. Okay, so you've got carbon, one bond oxygen, one bond carbon. That is an ether. Let's see, while we're here, I just pulled this apart, left that empty hole on the red ball. If we put a oxygen, that is an oxygen. If we put a hydrogen on it, like so, now it's a little dog. Woof, 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 woof. Sorry. If we put a OH on this carbon, then it is hydroxide or hydroxyl, same thing, kind of. They are the same thing. It's just whether it's acting covalently or ionically. But OH, OH, OH. I got to tell you, doing this in front of the screen and trying to make sure I have everything in the screen is a little bit awkward because everything, it's like a mirror. Everything works backwards. It's not like a mirror. Everything works frontwards. I push this to my right and the screen, it goes to my left. It's like you watching it from your side and me watching it from my side all at the same time. All right. Now I'm going to go back to here. Now, by the way, if this isn't working right, if like now you're supposed to be seeing notes. If when you're supposed to be seeing notes, you see a big picture of me or somebody, let me know so I can fix it. And if when you're supposed to be seeing me and these molecule models, if you're not seeing it, let me know so that I can fix it. All right, the next one on our list is carboxylic acids. Now, carboxylic acid is an acid. The carboxylic part of the name means it has, all right, just a minute. Stink pot, stop that. The carboxylic, gotta get the pen back, I guess. The carboxylic part of the name means that it has this. That's called a carboxyl group, which I did not put in the notes. If you care, it's this word right here, carboxylic, without the ick on the end. It's called a carboxyl group. So these are carboxylic acids. Notice that it is made of a double bonded oxygen, which would be like a aldehyde, and an hydroxyl group, which would be like an alcohol. So it's kind of like a aldehyde and an alcohol at the same time. Notice this. This is pretty important. on the same carbon. If they're not on the same carbon, then it is an alcohol and a ketone or aldehyde, depending on where they're located. They have to be together on the same carbon. The double bonded oxygen and the hydroxyl group have to be together on the same carbon in order for this to be a carboxylic acid. So I'm going to switch back to the camera and show you the model. So let's see, I think I have to stop sharing. It's me. All right, so here was our alcohol. Now this would be, let's see. This is ethanol. This is the alcohol that's in gasoline and beer and wine and all that other stuff, ethanol. And if we take these two hydrogens off, and replace them with a double bonded O, so bendy pin, bendy pin, now it's what? Like a seal playing with a ball? Sorry. There we are. OH, right here. OH, like the alcohol. Double bonded O, like the ketone, but they both connect to the same black ball, the same carbon atom. So it is not an alcohol or an aldehyde. It is a carboxylic acid. Oh, sure. Yep, don't do this switching back and forth enough to get comfortable and easy with it yet. All right, next is esters. Kind of like, this is not a pun, kind of like the woman in the Bible. So esters, right here. Okay, these contain a double bonded oxygen and an oxygen between two carbons. So that's kind of like putting together an aldehyde or ketone and a ether. But key is they have to be at the same place, on the same, one of them, let's see, just a minute, at the same place. So what has to happen here is the double bonded O has to be connected to one of the two carbons attached to the O in the middle. Which makes me think there ought to be a good pun based on the Ohio song, but it's not coming to me right now because the Ohio song is round on the end and high in the middle. Something on the end and O in the middle. I don't know. Never mind. So let's see. Let's look at that. Remember, by the way, before we look at it, remember that R, and R can include the C that's next to it. R is just regular. Sorry, I'm writing with my fingertip, not super well. Regular C and H stuff for R. All right, that looks like Railun. So let's see, back to the camera. So if we take this hydrogen off, we have an O attached to a carbon, but it's got a hydrogen on the other end. And we've got a double bonded O on the same carbon. So if we take this off and put a carbon, and it needs another hydrogen to fill up that hole right there, has to have 4 bonds. So now we've got an O between 2 C's. So the O between 2 C's is like an ether. And we've got a double bonded O attached to the same C, that the other O is attached to. So with the O between 2 C's and the double bonded O on the same carbon, that is a, whatever I'm talking about now, and I just lost my train of thought. That's a ester. So, hoping these make sense. Some of the quizzes, no, how can I do that? Normally, I would give you pictures and you would have to name what they are. But unless I do it on a worksheet, I can't easily do that. So we'll see. Maybe when I ask it on quizzes, it'll be like, which one of these has a double bonded oxygen and an oxygen between 2 carbons, or what am I looking for on an ester or something like that. There are a couple left to go. Amine and amide. And the thing that sets the amine and the amide apart, I'm going to come back to them tomorrow. I'm just going to start with them today. Not going to take much time. We've been here about close to half an hour, even counting the first couple of minutes when I was driving in. But notice that what makes amine and amide different from the rest is that they have a nitrogen in them. So I'm going to have to spend a little time on amine and amide, because sometimes R can be just hydrogen, and that confuses people. So I'm going to need to dwell there for a while. All right, so if you have any questions, I'll take them now. Otherwise, that'll be it for today. Sorry that you had to wait a little bit at the beginning. But have a good day.